Paul Butler of Carnegie's Department of Terrestrial Magnetism and Stephen Vaught of the University of California, Santa Cruz have led an international team of astronomers in discovering so-called super-Earths in orbit around Sun-like stars. Super-Earths are rocky planets larger than Earth but smaller than gas giants. The team used years of observations from the W.M. Observatory in Hawaii and the Anglo-Australian Telescope in New South Wales, Australia. The researchers used the subtle wobbling of the stars caused by the planet's gravitational pull to determine the planet's sizes and orbits. One of the planets orbits a star designated HD 1461, located 76 light-years from Earth and visible in the constellation Cetus. It has a mass of 7.5 times the Earth, is intermediate in size between Earth and Uranus, and orbits its star once every 6 days. The other planets orbit the bright star 61 Virginis, which is visible with the naked eye in the constellation Virgo, is only 28 light-years from Earth, and closely resembles the Sun in size, age, and other properties. Researchers found evidence of 3 low-mass planets, the smallest of which is 5 times the mass of Earth, and speeds around the star once every 4 days. The innermost planet is so close to its star and so hot that it glows visibly. This simulation shows the temperature patterns in its global atmospheric flow as it orbits the star.
Well, in this case, these planets both orbit stars that are similar to the Sun. So the fact that they're in small orbits that are typically like 4 days or a week or so, means that they would be too hot, of course, to support life or liquid water, at least as life as we know it. They point the way toward finding similar planets and similar orbits around nearby M dwarfs, which are stars that are typically less than half the mass of the Sun and typically put out less than 2% the energy of the Sun. And these sorts of planets around M dwarfs actually would be in a liquid water zone. So we are knocking on the door right now of being able to find habitable planets.
The wobbling effect the planet caused on its star was one of the smallest ever detected.
Well, the trick is in this right now, the amplitude, the semi-amplitude of the planet, the inner planet around 61 Ver is 2.1 meters a second. And the individual measurement errors from each measurement are typically of more than 2 meters a second. So we're in a regime where our measurement uncertainties are comparable to the signals that we're looking for. So, human psychology strongly drives you to making a detection, whether there's a detection or not. And one has to be very, very cautious at this level when you claim a discovery. And what gives us the confidence is that we see the signal from 2 separate telescopes, and that the 2 signals match up perfectly.
The variety of planetary systems discovered in the past decade has astonished researchers.
There are a couple of shocking things here. Prior to the discovery of planets, and we're only talking now 15 years ago, everybody was certain, both high-level stellar astrophysicists and theorists and science fiction Hollywood producers, everybody was convinced that all planets would look like our own. That there would be giant planets in distant orbits and smaller Earth-like planets in closer orbits, and they'd all be in happy circular orbits. And in fact, this has really revealed the incredible poverty of the human imagination. Almost no planetary systems look like our own, and we're now coming to the conclusion that these bizarre systems with small planets and close are pretty common. There are now about 5 or 6 of these things, and including the 2 that we're releasing right now. And we live in a very wacky universe, and we're kind of the oddball. We're not normal by any stretch of the imagination.
The discoveries are reported in 2 papers in the Astrophysical Journal. This is John Strom for the Carnegie Institution.